Hello, this is Camille Fairborn from Utah State University, and I'd like to welcome you to today's Cause Teaching and Learning webinar. We're pleased to have as our presenter today Dr. Silas Bergen, who is an assistant professor of statistics at Winona State University. For today's webinar, he will present a version of a talk he gave at JSM in 2016 titled A Data Visualization Course for Undergraduate Data Science Students. The way the webinars work is that all listeners are muted during the webinar. You can ask questions at any time by typing them in the questions box. We'll be sure to ask those questions either as we go or towards the end and give Silas a chance to respond. You can also use the chat box if you are having any technical questions. At this point, I'll turn things over to Dr. Bergen. Silas, go ahead.
Thank you. Thank you so much, Camille, and thank you, everyone, for taking time out of your busy end of semester or quarter or what have you schedules to be with me today. I appreciate that. So yeah, as was mentioned before, I'm going to be talking about a data visualization course that is a pretty key component of the data science curriculum here at Winona State University. But before I actually go into the specifics of the data visualization course itself, I wanted to give you a little bit of an overview about the data science curriculum at Winona State as a whole. So the core courses that we're working with here kind of come in these three primary chunks. So there is a statistics component, and that's kind of your intro stat, intermediate statistics, regression. There's a computer science component, which is basically CS 1 and 2, and then their more advanced database management systems course. And then these three new courses that have DSci prefixes, and these are the new courses that were developed specifically for the data science curriculum. The statistics courses are taught by statistics faculty here at Winona State. The computer science courses are taught by computer science faculty, but these DSci courses are also taught within our department, and accordingly, because a lot of this is new, we had to think about, how are we developing these courses? What are these courses going to look like? And we're still kind of iterating through this as we've run this curriculum now for a couple years. Spring 2015 was when we started this. So as far as those three data science courses go, those three DSci courses, a little bit of detail about those. So DSci 210 is kind of your data science 1. I suppose you could think of it that way. This is your principles of data aggregation and summarization, introduction to data tools, mostly Excel. My colleague Chris Malone has been teaching this one. He starts off in Excel, moves into R a little bit, has touched on Python, I think, in one of the semesters as well. We're still trying to figure out a little bit what we're doing in all of these courses, but DSci 210 in particular. He does some unstructured data in that course, so some web scraping, some text analysis, and Data Science 210 is a prerequisite for DSci 310, which is the data visualization course. There's 310, of course, which I'm going to talk a lot more about in a little bit, but the other kind of main data science course is the management of structured data, DSci 325, and we kind of, or at least I have kind of begun to think of that course as data science 2, so the second semester in data science where students get more of a introduction into programming. There's a lot of SAS, a lot of R that we use in that course. dplyr is a pretty heavily used tool in that course as well. So DSci 310 and 325 are more or less companion courses. One is not a prerequisite for the other. A lot of students take one without having had the other one. So that's a little bit of a background into our DSci curriculum here, or at least these are the required courses. There are some upper level electives as well that are not required, but these are the meat of the curriculum here. So without further ado, more on DSci 310, data visualization. So I want to kind of walk through the primary components of the course, walk you through the outline, and as I walk through the outline, give you some examples of assessment items, in-class activities that we do for each of the components of the course. So when the course starts out, I don't have the students actually doing any data visualization for several weeks. So we talk about visualization theory and best practices for the first, I'd say, 3 or 4 weeks of the course. This draws a lot from the work of Ed Tufte, Cleveland and McGill, and Hadley Wickham. And this is more on, how do we perceive information? Are there better and worse ways to display quantitative information? The answer is yes, and then we follow up with, well, what are those ways? There's a lot of critiquing in these first couple of weeks, so I'll have some examples of visualizations that I pull from the web. There are obviously a lot of data visualizations out on the web, and I'll ask some questions, kind of guide the students through some of the things that I want to think about, have them thinking about that pertains to these best practices. So before we even go into creating the visualizations, I want the students to be understanding, what makes a good visualization, what are some of the pitfalls that you want to avoid falling into, and just to become a better critiquer of data visualization. So here's an example of an assessment task that I've given them in this first section of the course. This is a Tableau data visualization that I pulled from the web. This is looking at the shelter problem, basically how much is spent on shelter for homeless population and different discrepancies in the homeless population across the United States. The questions on the right you can see are the questions that I posed to the students. So what variables are being encoded in this visualization? What are the EPTs used to encode them? So EPT stands for Elementary Perceptual Task. It's an acronym used by Cleveland and McGill. Something like using length or color or size to encode quantitative information. So for example, you could see that the total homeless population in this kind of popsicle chart over here, the length of the bar is encoding the size of the homeless population. So that would be an EPT that the students would need to identify. So there are questions like that. What variables are actually being encoded here? Trying to get them to make the mapping between a spreadsheet and a data visualization. Then I ask them more specific questions about the visualization. So for example, what do you think about this bar chart down in the lower left-hand corner? Is it effective? Is it confusing? What things could be done to improve it? One of the things that I in particular think is particularly confusing about this bar chart is the bars showing the total homeless population, and then the sheltered individuals is this kind of swimming pool shape down here. And we have the conversation in class, why do we need this different type of area chart, I suppose, along with these bar charts? Does the different way of displaying that information actually confuse, or does it enhance the viewer experience? And then finally, something along the lines of question 3 here, how is funding encoded? And if the students look very carefully and read the fine print, funding is actually encoded in this map by the shading of the states. And if I wanted to look at a relationship between funding and percent sheltered or something like that, there's basically no way to do that. I have to compare the size of the points on top of each region to the color of the shading underneath. So getting the students to think about ways to improve upon the visualization as is. So this is an example of a critique. Here is another one. Part of my intention with this first part of the course is to get them to expose them to different ways of visualizing data. So this is called a chord chart and is often used for mapping migration. And this particular chart looks at migration between cell phone companies. So again, I would ask them, what are the variables that are being encoded? What EPTs are used to encode them? What are insights you can glean from this visualization? Chord charts in particular, because they are not very common, students or the general public may have trouble kind of understanding what's going on here. And so I ask them, do you like the chord chart? After you kind of get the hang of interpreting it, what do you think about how effective it is? And then the nice thing about this particular chart is you can actually download the data, and then we looked at, would a stacked bar chart be more effective? So for example, having a chart that has all of the customers from Samsung broken up and color-coded by where they migrated to. Is that a better way of visualizing these data? It might not be as pretty or as interesting or as awe-inspiring, I suppose, as this chord chart, but might it actually be more effective, communicate the information more efficiently? So that's kind of the first few weeks of the course, and then we actually dive into creating data visualizations. So I have handouts that I create that talk about, the primary ways of visualizing data: univariate, multivariate, geographic, interactive and static dashboards. This takes up kind of the bulk of the course. The tool that we use in DSci 310 is Tableau. I taught this course for the second time just this fall, so I just finished up teaching this course for the second time, and I got to introduce ggplot for a couple weeks. I'll talk a little bit more about that maybe at the end. But Tableau is the primary tool that we use. I really wanted the students to learn a tool well enough that they could think more about visualizing the data than they had to think about learning the tool. And so Tableau is the tool that we chose to use. That it takes a relatively short amount of time to get the hang of it relative to other tools. But a little bit more about that, I think, on my next slide. So in terms of assessments for this second part of the course, the students were required to do a number of design tasks. The way that these worked, I would provide the students with a specific data set. I would give them very specific questions, and I said, visualize the answer to these questions. One thing that I did this past semester for the first time was I implemented a peer review phase. And this was actually a result of student evaluations from the first semester I taught this course, and I thought it actually worked really well. So the way that this worked was after the students made a first draft, they uploaded it to this free website called crowdgrader.org. If you haven't heard of CrowdGrader, it's a great resource for doing peer evaluation, not just for Tableau visualizations, but for computer code or for introductory statistics assignments. It's really, really great. I recommend that you check it out. So the students would upload their visualizations. They would be required to review 3 peer visualizations, and then they would also get the feedback from 3 peers critiquing their own visualization. Then after that peer feedback phase, they had a couple days to incorporate the feedback and then submit a final draft to me that I would grade. So I really, really liked how this worked out this semester. Not only did the students get to see what other students in the class were doing to visualize the answers to the same questions, but they then also got feedback and could incorporate that feedback before they submitted a final draft to me. So I mentioned I was going to talk a little bit more about Tableau. This is an ongoing struggle, I suppose, in terms of what software to use in this course. Tableau, some of the pros of using it, it is point and click. So students who come into this class without having any sort of coding background can understand it relatively quickly. There is easy interactivity, and what I mean by interactivity here is like a crosstalk style. For example, if I have a scatter plot and a bar chart and I want to be able to speak to one of those by interacting with the other, it's easy, very easy to do that with Tableau. Tableau Public makes online sharing very easy, and like I said before, it is a relatively shallow learning curve, so students can usually master it by the semester's end, and they really like the ability to become a Tableau master. That's come up a couple times in the course evaluations. The cons are it is easy to create interactive visualizations in Tableau, and I think students get so wowed by that that they start making everything interactive and kind of lose sight of communicating things effectively. Tableau Public is the only free in general Tableau Public is the only generally free resource. Tableau Desktop, which is what we use, we have it through an academic license, but if students were to go out and be doing whatever in their jobs, Desktop is not free to them necessarily. You have to have your data really ready to go in a pretty clean format before you start visualizing in Tableau. You cannot do much data manipulation. It is not a data wrangling tool, so that took some students some time to understand, okay, what do I need to do to some of these data sets to actually get it into a form that I can read into Tableau and start working with. And because of Tableau's point and click interface, it does sacrifice some flexibility that you might have with some other options. So anyways, just an aside on Tableau, let me now show you some examples of design tasks that I would give to students. So this would be one example, using data from the American Community Survey. Create 3 visualizations that address the following question: how does inequity in median income compare, looking at employed men to employed women across the country? And I gave them this following restriction. They had to visualize this data in 3 different ways. The first 2 ways were with a map, using different EPTs to encode income equality. And then the third one is not a map. So I forced them to try to get a little bit creative here. So this is an example of a visualization that a student created for this task. The first 2 maps on the left, you can see look at inequality in median income using color or size, but then the plot on the right doesn't use a map, and it actually visualizes the median income separately for men and women with the length of each line there, kind of showing, okay, what's the size of the inequality, and then ranked by the size of that inequality. So I thought it pretty creative. way to look at the inequality. The nice thing here is that you can actually not only see how big is the inequality, but what are the median incomes. So for example, in DC, we see shifted over to the right, yes, there is a big gap, but women in DC are making more or have a higher median income than many of the other states. So actually more information, I think, in this chart than with the maps. Here's another example using the CDC data to visualize teen pregnancy rates and some examples of specific questions that the students needed to answer. So how have the TPRs changed over time? Are there racial gaps, and how have those gaps changed? Which states have the best TPRs, which states have the worst, and which states have improved the most over the span of for which we have data, which was the 11-year span between 2003 and 2014. So this was also a little bit of a data challenge. This was the data that I provided to them to answer these questions, and along with the raw number of births and the total teen female population for each state, for each year, for each race, I also calculated the fertility rate for them in the data file. So this is just simply the teen fertility rate per 1,000 females. And one thing that they had to do was basically ignore this column, because if they're going to be looking at the teen pregnancy rate, across all years or for, across all races, you can't just average these fertility rates because the sizes of the teen populations are not the same. So they had to be very, very careful with that and kind of avoid misusing that column and just creating a raw average. Most students picked up on that, but there were a few who fell prey to this column of misdirection, as I have it labeled here. Anyways, here's an example of something a student did that I thought was very nice. Showed the overall teen pregnancy rate across all states and for all races. It's decreasing, as we can see, showing the racial gaps in the teen pregnancy rate. And then this particular student created an interactive piece down here where if you click on a state, you'll see the state-specific teen pregnancy rate for each race, and then the overall trend as well. This does not have, this is just a screenshot, so it doesn't have the interactivity, but I thought was very nice. Some nice kind of aesthetic formatting as well. So I've covered the first two primary elements of the course, the critiquing phase and then the kind of learning tableau, starting to actually create some visualizations. And then the bulk of their grade is actually based on a couple projects. So there's a midterm project, and that's a group project, and that is a project where I give the students a data set. It's usually hefty, or maybe multiple data sets that they have to merge in some way. And then there's a final individual project, and that's where the students get to go out, choose a data source that's interesting to them, create a dashboard. And for both the midterm and the final projects, the students have to present with oral presentations, which is actually really, really fun to see them kind of talk through what they've learned through their data visualization projects. So here's an example of a midterm project that I gave. If you go to the Bureau of Justice Statistics, they have lots and lots of data. The problem is that, for example, in their reports, they have tables like this. This is table 20, and as you'll notice, a lot of information in this table, but it is tabular format. It's very hard to understand kind of what's going on in this report. So the task that I gave the students was, okay, given this entire PDF, of which there were several dozen different tables, create a visual report of this periodical of the mortality in local jails and state prisons. So that was their midterm task, their group project. So this is just one dashboard that one of the groups created. They looked at, okay, what are the highest causes of deaths of the local inmates? This is for local jails. How do those deaths change over time? And then how do those deaths vary across year by race? And I use this one as an example because this particular pie chart here has both really positive elements and some, let's just say, things to work on as well. The positive is that it's a really creative take here to kind of make each point a pie chart showing, okay, for each year, what proportion of the inmate deaths are, of each race. The problem is pie charts, as we talk about kind of in the first 3 weeks, are not necessarily the best way to create comparisons between different categories. Maybe would a line chart have been better, one line per each race? So that's one thing that we kind of talked about as a result of this data visualization. Another project that I really liked was turning the current playlist data into a visualization. So the current is basically a kind of indie music station that operates out of the Minneapolis-St. Paul area. The students had to go and scrape this playlist data from the year 2015. So they looked at not only, what are the songs, but who are the artists, what time were those songs played, how often were they played, and kind of make a visual report of this radio station's playlist data. So we had to use RVest to actually go through and scrape the data and then turn that into a visualization that looks like this. This visualization allowed the user to filter by, okay, the top 25 or top 30 or top 40 songs, and then if you click on any one of these bars, so for example, this song Lampshades on Fire by the artist Modest Mouse, clicking on that bar would show, okay, what are the trends of when that song was played, what are some of the other top played songs by that artist, and I thought, it was a really nice way of interacting with the playlist data in a way that would not be possible just by going to the website. So final projects then, what are some examples of projects that the students had to create where they chose their own data? And I have been really impressed by the output for the students' final projects. At this point in the semester, they are pretty well versed in Tableau. They have a pretty good feel for it and are becoming Tableau masters, as they like to say. This is one particular example. One of my students was interested in the Millennium Development Goals in Southeast Asia. He created a nice introductory page that explains, the motivation of the problem, and then looked at, okay, how is the UN doing as far as its Millennium Development Goals go for some of these Southeastern Asian countries. He looked at data from the World Bank, had to get that data, query it from the World Bank data source, and then created a nice set of dashboards to investigate the progress towards those Millennium Development Goals. So this is one example. Another example that I thought was really interesting was this particular project that was titled, Did the Citizens of the United Kingdom Get What They Voted For? And this looked at, for each party in the UK, what percent of the people for each district voted against that party, and he called that the misrepresentation error. So for example, he has two bars here looking at the percent of the vote that each party got, but then the number of the seats in parliament, and he called that the misrepresentation error, and then shows that down here with these other bars. So I thought a really creative, pretty simple but pretty creative way of looking at, okay, what are the differences between which parties were voted for and which parties are actually represented in the parliament. This is then his interactive piece where if you click on one of the particular constituencies, it would show you the vote percentages for each of the parties, and the number over here is that misrepresentation error. So what percent of the vote went against the party that actually won that constituency? So red would be a very high misrepresentation error, green would be very low. One student was interested in NASA data, and she looked at where have meteorites landed on Earth over time. She made this pretty cool looking dashboard that shows, okay, where have meteorites fallen over time. If you were to click play on this, it would actually show a kind of time lapse of where these have fallen over time, and then the size of the meteorites, or the mass, I suppose, it would be in grams as well. So kind of concluding the examples in the course overview, what are some big picture things that I think have worked well in this course? I really like the peer review and the editing cycle in the design phase. I think that incorporates not only learning how to visualize data with Tableau, but also some of the critiquing that the students practice in the first few weeks. They get to continue practicing their critiques even as they're learning now how to create visualizations. Some of the design tasks, so for example, that CDC teen pregnancy rate design task, what I would often do is after I had gone through and graded them all, I would pick out 3 or 4 that I thought were the best, and then I would show those to the class, and we would talk about what were the strengths of each of those and what were some of the weaknesses of each of those. And what that did was allow the students to kind of see what some of the stronger students in the class were doing, which I think really helps to motivate them and get them to think out of the box as well. Some of the biggest challenges, I am a statistician by training. I am not a graphic designer. And teaching the students how to be creative, it was a very big challenge for me and still is a big challenge. One of the students in their course evaluations said, when I asked what's one way to improve this course, they said, have all the students take Art 101 before they come into this course, which would be great, and I would love to have that background as well. I think I should take an Art 101, but being able to teach creativity, teach aesthetic appeal, that's very far out of my expertise. So maybe in the future, looking for some way to collaborate with people who have more expertise in that area would be great. A constant challenge is emphasizing insight over data dumping. I think as students learn how to use Tableau, they can get carried away with it and just make visualization upon visualization to the point where a single dashboard will have 6 different images on it, and it just becomes overwhelming. So teaching them not only how to create visualizations, but also how to convey information with them. When we do the oral presentations in class, they do a little bit of that. So there's a part in the oral presentation rubric where they are required to provide an insight from their design and not just show us and walk us through the visualizations that they've created. That helps a little bit, but I think I need to learn how to emphasize that more. Communicating with data, not just making many things. Emphasizing that editing process, I think, is very important. So that concludes my talk. I would love to hear questions. I'm happy to provide any resources that you are interested in. So yeah, at this point, I'll just open it up to questions. Thank you again for listening.
Well, thank you, Silas. This has been great. I have a few questions from attendees so far. The first one was, what are the math prerequisites for your degree plan?
For the data science program as a whole? Mm-hmm. We are less mathematical than the statistics curriculum. Man, that's a great question. I think Calc 1 is a requirement for the data science degree, but not anything beyond that. Calc 1 or Applied Calc, I believe, are the extent of our math requirements.
Do you do any more math after they get in, or just the Calc is the only math they need?
Well, so is the questioner asking about prerequisites to get into the program, or in terms of what they need to graduate with a data science degree?
I think the original question is, what are the math prerequisites for the degree plan? And then my additional question was, what are the additional math requirements you give them?
So I suppose we don't have any, I mean, anybody who wants to can declare a data science major. We do not call those applications and say you don't have the prerequisites, you can't enter our program. We'll accept anybody. But then to graduate with a degree in data science from Winona State, I believe Calc 1 is a prerequisite, but no additional math beyond that. One of the courses that's an elective, but that we're seriously considering making a requirement, is the DSci 415-425 sequence, which is basically unsupervised and supervised learning. Mm-hmm. Those are upper level electives right now, but I think they're very essential to anybody who claims to be a data scientist. We're thinking about making those requirements, and those would be more, not necessarily math, but more upper level programming, machine learning, deep learning, supervised methods, so neural nets, boosted trees, those kinds of things. Okay.
A couple of other more general questions, and then we have a few that are specific to some of the visualizations. How much time did it take to develop this course in particular?
I am the beneficiary of a lot of work done before I actually arrived. So when I arrived, the program had just begun. I started at Winona State in the fall of 2014. I believe that so my colleagues Chris Malone, Brent Deppa, Tisha Hooks, April Kirby, they are the primary instruments behind developing and doing a lot of the footwork for actually putting the program in place. I believe from the time it was a germ in the mind of Chris Malone to full implementation, 2 to 3 years, I want to say. And then spring 2015 was our first offering of a data science course.
Okay. Do you have a required text for this class?
We do not. I have a couple recommended texts, but no requirements.
Someone's asking, could you show the names of the references you mentioned at the beginning? I'm not sure.
The references is this person speaking to on slide 5?
I'm guessing. I don't know for sure.
So these are actually, the Tufte book is one of my recommended texts, and that would be the visual display of quantitative information. If you Google that, you could find that on Amazon. Cleveland and McGill, there are just a couple of academic articles. I'd be happy if this person wants to contact me to send out the exact names of the articles, but if you Google Scholar, Cleveland and McGill, there are a couple articles that come up that I use. Hadley Wickham, I think I just pulled some information from his website, so not necessarily a book, but just some PowerPoint slides that he had that he's taught in a class before. The other recommended text that I have is Communicating Data with Tableau, and that's by Ben Jones, who is employed by Tableau Public. So that's another recommended text.
Okay, so along with that, Carolyn asked, how long did it take you to learn Tableau? Estimate.
Myself personally, I probably spent, I spent the summer working with it, the summer before I taught the course, and that wasn't every day for 8 hours, but that was a couple hours a day, and by the time the summer was over, I felt like I had a pretty good feel for it. Of course, the first time I taught the course, I screwed up in class, which I then learned from that as well. So it's been a multi-year process, but I think if you spend a couple months really diving into it and trying to learn it, you can master it in a pretty short time. Have enough of a feel for it to be able to teach it, I think.
Okay. And how many students are in your class each quarter?
So the first time I taught this course, there were just 12, I think. And the most recent semester that just ended, I had 24. So it already doubled in a year, and our data science curriculum as a whole is expanding very rapidly. So I wouldn't be surprised to have over 30 the next time I teach this course.
Okay. Question from John says, how do you make sure that in your grading you don't incentivize a data dump?
I don't think I have enough of a rubric for that at this point. I mean, I have a rubric, but I think not doing a data dump needs to be part of that rubric. So when I spoke to the challenges, I think that's one of the things that I'll try to improve on next semester, is making sure that the visualization is succinct and easy to understand. So yeah, I continue to revise my rubric. There are like 8 elements on it right now, but that will probably be something I'll need to add in the future.
Do you have an issue with peer reviewers stealing ideas from other projects when they're working on the same data?
I haven't really seen that. What I have seen, and I don't necessarily think this is a bad thing, is a student will see, so for example, let me go to slide 11 here. So this quote-unquote DNA chart on the right is a particular technique. Maybe I'll see a student who, peer-reviewed a student who used this technique, and then later on the student who reviewed this graph will use that technique for a later project. But I don't really see straight-up stealing of ideas from visualization to visualization on the same task. But that's actually something that I am not necessarily opposed to. All of these different techniques, I design visualizations because I've seen that somebody else did this, and so I'll take that and I'll tweak it. A lot of visualizing, I think, is going out and seeing what other people have done, and then kind of compiling a library of ideas that you can draw from.
So we've got a few more questions about Tableau. What do you see as the advantage of the desktop version over Tableau Public? And then do you spend a lot of class time teaching Tableau, or do you expect the students to pick that up?
Sure. So the primary advantage of Tableau Desktop over Public is that you can save a file locally on your machine or on your hard drive. Tableau Public, you cannot save a file locally. You have to upload everything that you're working on to your Tableau Public profile. So basically, you have to upload everything that you're working on to their server. That's not necessarily a bad thing, but if you don't want your data up on the server, then you're stuck a little bit. As far as the capabilities of the two tools, there is basically no difference. Tableau Desktop allows you to connect to a lot more varied sources, so databases, Google BigQuery, for example, whereas Tableau Public, you're restricted to, CSV files, Excel files, that kind of thing. So those are the primary differences. You could definitely use Tableau Public and just make sure that all your data sources are a CSV file or an Excel file. What was the other question?
There's so many of them. I'm trying to keep track. Where did it go? Do you spend a lot of class time teaching Tableau?
Oh, right. Yes. And that's something I'm trying to figure out how to balance as well. I do teach so attendance is also a required part of their grade. So if they're in class, they need to be in class to earn 10% of their grade or something like that. And in class, I do walk through a lot of here's how to use Tableau, here's the creation, but then sometimes I'll say, okay, here's the finished product, and you need to now work to create this or to duplicate this without actually telling them the steps to get there. So there's kind of a mix of me showing them the steps and then me saying, here's a finished product, you figure out how to get there.
So do you see that as better than, I mean, obviously you spend a lot of time with Tableau, so some questions are, is this better than ggplot? Is it better, have you considered Plotly?
Yeah.
What are some other things
yes.
that you're thinking
Yes.
of?
And
yes.
That's always the perpetual question, I think. I actually didn't speak to this very much, but I spent 2 weeks going over the basics of ggplot this semester. I had more time this semester because I, refined things and made things more efficient. So I had time to spend a couple weeks on ggplot. I think on student evaluations, the feedback on that was mixed. Some of them said they really liked being exposed to ggplot and wished there was more, and then some of them said, don't do ggplot next time. It was too strange to learn a brand new tool right in the middle. I wish we could have spent more time on Tableau and expanding our, mastery of Tableau. So mixed feedback there. I mean, I kind of spoke to a little bit of the pros and cons of Tableau, and I think it comes down to the benefits of being able to get up and running relatively quickly compared to R or ggplot is a big advantage in my mind. So.
Okay. Really having to pick and choose here. There's so many questions. Do you have art and data science or art and design students in your major? Are you anticipating some?
There have not been any yet that I know of, but I would have a hard time seeing an art or design major excel in all of our courses, but they definitely could take this data visualization course and add to it, I would think, or contribute very positively to it.
And then speaking about the cross-disciplinary stuff, did you have some good cooperation with your CS department, or did they want to provide the major? How did that go down?
There is actually a pretty strong working relationship right now, and actually one of the reasons our data science major is expanding so rapidly is they have really pushed this major to their students. So in advising, the CS faculty have recommended this major. It benefits both. I mean, a person in data science has to take those CS courses and some stat courses, and then these, unique DSci courses as well. So, in the development of the program, CS was very instrumental in helping craft the outline and everything as well.
Could you speak for a couple of minutes about how you get your data? Looks like you're getting some from the JSC data sites, but how do you find good data? How do you advise students to find data sets? That kind of thing.
Sure. I look for data that I think will be broadly interesting. So I mean, I'm a big baseball nut. I try to not use baseball data for every possible example because I don't think that's necessarily interesting to students. So I try to find broadly applicable data. I try to find data that is illustrating a point that I want to emphasize. So for example, the CDC data, I wanted to make sure they understood how to visualize rates appropriately, and that was a key or an important aspect of that data set. Another thing that I'll do sometimes is I'll go to the Tableau public gallery and I'll just browse their featured visualizations. And a lot of time you can download those workbooks and get the data from those visualizations, which is nice because then I can tell the students, I'll give them the CSV file, say, okay, make this visualization, and then we can look to, here's the featured way of visualizing these data that was on Tableau Public's gallery. So that's one thing that I'll do also.
Do
As
you
far as their
clean,
final, yeah, sorry.
do you clean and tidy the data for them?
At first I do, and then for the group project and for the final project, I do a lot less. So for example, that BJS, I just gave them the PDF and I gave them the zip file with all these Excel spreadsheets in them, and I said, go to town. So,
Okay. Oh, and then that thing about JSE, Robin Locke says that it looks like you've got some really good stuff, and if you wanted to share that as in the data sets and stories articles in JSE, I think a
hmm
lot of us would be really happy
okay,
if you were to do that one of these days.
great.
There's some other questions kind of at the beginning about some of the examples you showed. Could you just remind us what the EPT stands for again?
Oh yes, that's yeah, wasn't very clear about that. I think so. Elementary perceptual task is what that
Oh,
stands
there we
for,
go. Okay.
and that is from the Cleveland and McGill. That's where they talk about that. Um, so that's using size to encode quantity, or a color ramp, or the height of a bar, things like that. That's what elementary perceptual task.
So do you have students point out which of these principles and things they use in their projects?
Um, I do not, but one of the criteria in the rubric that I use to grade them is were the EPTs that you chose appropriate. So, are you using hue, for example, to encode quantity comparison? That's not necessarily an effective way to compare different quantities to each other. So I am checking for that in my rubrics as I grade them.
Okay. And then just some other, I guess, suggestions from from some attendees about
hmm
textbooks about the Cleveland and McGill.
Yeah.
They said that Naomi Robbins has a good book for that,
Okay.
and that Cleveland has at least two books, one called The Elements of Graphing Data and one called Visualizing Data. So
Okay.
we
I
can,
believe I actually have Naomi's book, so that yes, I do. And I did use that as well. She gave that to me after my JSM presentation, and that was a great resource as well. I took some examples from that to use in the course. Because I'm not spending a huge amount of time, I don't have any required textbook. Um, but yeah, that was definitely a very helpful resource.
okay. And then I think we might be coming all of the way. Let's see, where did it go? I can answer one of these questions. This presentation and the slides will stay on the CausWeb website. They'll be posted there within the day today, and I think they stay as long as CausWeb's going to be around. So you can recommend this presentation to any colleagues that you like. Uh, how large are the groups for the students in those group projects? And then
Yep,
do you present the research question to them or ask them to come up with the research question?
sure. The groups are limited to 3. I was lucky and had 24 students this past semester, so I could perfectly divide into 8 groups of 3. Um, I do ask the students specific questions that I want to see, um, but they are a little bit more vague than some of the design task questions. So the students have a little bit more leeway as to what they want to show and what they want to communicate.
Okay, can you put your contact information back up
Yep,
and we'll let people, I'm assuming you're open to questions and contact for
absolutely.
people that want to maybe get in and see more of what you've done. And we are about out of time for today, but thank you all for attending. We
Yes,
do
thank you.
have and thank you for presenting, definitely. We do have a webinar slotted for January 17th. We're still firming up the deadline details for that, and hope you'll keep your eye on your email or on the CausWeb website for more information about that. Thank you all for attending and have a great end of the semester.
Thank you.